are absent. Okay, so today is which class number? Today is class 9, I guess. First thing what we will do is multiplexer ICs. And we are going to see 4 types of IC. Number 1 is 74153. You will have to remember these IC numbers. 74153 is a dual 4:1 IC. Dual 4:1 mux. Okay, dual 4:1 mux. Next, we have 741.
What is the 74?
Huh?
What is the first IC's full name? 74?
74153. Are you able to see my screen? On the screen I have written 74153. It is a dual 4:1 IC. What do you mean by dual 4:1 IC? It has two 4:1 IC in it, and enable pin is common. Of course, I will talk about the internal diagram of all this. I am listing here so that you know what all you are going to study today. Second one is quad 2:1 IC. 74157 is quad 2:1 IC. All of you see on the screen. I am writing on the screen also. This is your 1 IC, second IC. Okay, then I am giving you third IC. Third IC is 74151. This is a 8:1 IC. Okay, then fourth IC I will show you is 74150. That is 16:1 IC. Okay, so these 4 ICs we will see. Now 74151 and 74150. These are simple ICs where you are simply having one 8:1 mux and one 16:1 mux with a low enable. Enable is always low. Enable is active low. And rest all are active high. Enable is active low, and data input and output lines are active high. So this you have to remember. Okay, now let us quickly go on to the pin details of 74157. Okay, that is a quad 2:1 mux. So let us see quickly 74157 quad 2:1 mux. Quad 2:1 mux. So what do you understand? I have 4 2:1 mux in this IC. Okay, so let us see how it is. Why it is important? Because you will be asked to design things using it. As I already told you, enable is a active low in multiplexer. And what you have to remember in this, all the 4 2:1 IC in this have a common select line. It has a common select line, and all 4 multiplexer will be controlled with this common select line. Now next, because it has 4 2:1 mux, means you have to label things carefully. We should take care of 4 pairs of input, right? So 2:1 mux means what? 2 inputs are there, means a pair of input is there. So how we will name is, I will name it as 1A and 1B. 1A and 1B forms my first 2:1 IC's input, and 1Y will be my output. 1Y will be my output. So this is with respect to my first 2:1 IC. Now second 2:1 IC I will show like this. It is a 2A, 2B. It is second second 2:1 IC, and in front of it I am showing it is a 2Y. Same way I will show my third 2:1 IC, third 2:1 IC, and I have respective output. Same way I will show my fourth 2:1 IC's input and fourth output. I hope this is clear to you. You have to remember that it has 4 2:1 IC, and 1A, 1B, 1Y becomes first 2:1 mux. Then same way 2A, 2B, 2Y, 3A, 3B, 3Y, 4A, 4B, 4Y. These are the 4 2:1 mux. But the most important thing you have to understand that it has common enable, it has common enable, and it has a common select line. A common select line. If you want to write the truth table, if you want to write truth table showing the functioning of this IC, showing the functioning of this IC, how you will make? I am making the columns. I am making the columns and rows, and you need to fill in the blanks. So be ready to do it quickly. Okay. I am showing you that you have input. Okay. And which all are control inputs now? Can somebody tell me which is called as control input? Which is called as control input? See, you do not have control using your data lines. You do not have control using data lines. It is just a simply connection. So your output of 1Y, 2Y, 3Y, 4Y, these are simply your data lines. It is simply data lines, and the input also does not have any control. Input is also data line. Who has control then? You have only two control variable in any mux. One is your enable, which is active low, and other one is your select line. So in mux we have only two control inputs, that is enable input and select input, and your data input and data output are things only for the connection. It is not for any control. There is a difference between control and data. So when you are talking about control, enable and select is control inputs, and your 1A, 2A, 3A, 4A, 1B, 2B, 3B, 4B all are your data inputs, and 1Y, 2Y, 3Y, 4Y are your data outputs. So when we talk about truth table, we need to see how my control works. Okay, how my control works. Now you have to tell me what will happen if I keep my enable 1. What will happen? If I keep my enable 1, what should I write for rest of the columns in this row?
Don't care and zeros.
Correct. Very good. So if enable is active low and I am giving 1, select becomes don't care. It does not matter whatever select comes. And output is not connected to anything. And when it is not connected to anything, you will see 0 voltage there. Okay. Now if enable is active low and I give a 0, means it is in a working mode. And when I put a 0 here, as I told you already, that select line is common for all. So if I put 0, what will come in this row of 1Y, 2Y, 3Y, 4Y? All will be connected to its first input, right? So this 1Y is there, it will be connected to first input if select line is 0. So what is the first input? 1A. Same way, first input for second one is 2A, 3A, 4A. So 1Y will be equal to 1A. Then here it will be 2A. All will be connected to its first input if select line is 0. And if select line is 1, all will be connected to its second input. And second input is named as 1B, 2B, 3B, and 4B. So this becomes your truth table of 74157, which is a quad. 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 Which is a 2 is to 1 mux. Pod 2 is to 1 mux. So you need to remember this. And why it is important? Because sometimes you may get a question, saying that design something using 74157. So you should remember all this, then only you can design, right? So this becomes your first type of IC. Now let us go to our second. Any doubt in this one? Any doubt in this one? Let me know. If no doubt, we will go to the next one. That is 74153 dual 4 is to 1 mux. Now dual 4 is to 1 mux. Again, we have common select line, but we have separate enable pins here. And the truth table is little lengthier here. Truth table is little lengthier, and because so many conditions will come in this, no? So that is why. Now I can show you the block diagram as well as I can show you the pin IC. Now for example, for my previous mux also, I will give you the IC number, okay? Sorry, pin number. So 1A, let me show in a different color. Why? Because you, when you use it in lab, no, you should remember this number also. So select pin is pin number 1. Then 1A, 1B is 2, 3, and output should be near to this. So fourth one is here. Next you have your second IC 5, 6, and output for this is 7. Then your 8, you know, I hope that pin number 8 is always given for VCC, and pin number 8 is stored for those common input of ground and VCC. So you will not see pin number 8 here. So directly we will have pin number 9 here for the third IC, and pin number 10 and pin number 11 are your this one. Why this is happening? Because when you construct an IC and when you embed thing on the your silicon chip, it has to come like this. You will get to know about these details in your higher semester. So that is why third IC it becomes ulta. 9 is the output, 10, 11 is your input. Same way now 12 is your output, and pin number 13 and pin number 14 is your input, and your active low enable is pin number 15. Okay, so you can see that it is a 16 pin IC.
One doubt, ma'am.
Pin number 8 and pin number 16 is not shown here because pin number 8 and 16 is going for VCC and ground. Tell me your doubt.
Yes, ma'am. Over here, you started the naming as 2, 3 for the input and 4 for output, 5, 6 for input, 7 for output. Over here, you suddenly changed to 9 as output and
That is
11
what
and
I
10 as
was
input.
just now telling you. No, why this happens is when they fabricate the IC. When they fabricate the IC, the half of the pin will be left hand side, half of the pin will be right hand side, right? And this is a simple IC diagram I am showing, but I hope you know that any IC looks like this. Any IC looks like this with a notch here, and your 8 pins will be this side and 8 pins will be this side, right? Now you have to imagine inside we have a silicon wafer on which these ICs are fabricated. These pins are fabricated with its control logic. So when you do fabrication and all, then you will understand the problem associated with the fabrication. That is why when you come to your third and fourth IC, the connections are given like this. Okay, it is not my wish that I want to keep things in serial order. It's not like that. It depends upon the fabrication of IC. Okay, so when we do fabrication of IC, it happens this way. And same you would have seen in your AND or NAND and or ICs also. Okay, so this pin number is based upon the fabrication. Okay, so shall I go to the next one? Your next one is 74153 dual 4:1 mux. Okay, now let me give you both type of diagram for this. One is your block diagram, and here you have to remember that your block diagram will show two 4:1 IC. It will show two 4:1 IC because it is dual 4:1 as the name I have already written. It has separate enable pin. In 74157 you saw that it has a common enable pin, but here you have a separate enable pin named as enable 1 and enable 2, and but it has common select line, A and B common select line. So both will be controlled using separate enable but common select line. And as I told you that each one will have its own data lines, which will be called as 1D0, 1D1, 1D2, 1D3, and output is your 1Y. Okay, all of you should make all these things along with me. Later you will not be able to cope up with the same things. Okay, so all of you should draw along with me. So 2D0, D1, D2, and D3. So this is your second 4:1 IC. Okay. Now, if I give you the IC diagram, if I give you the IC diagram, all this you people need to remember. Okay. All this you need to remember. Why? Because you will be doing experiment also with this. So I am talking about 74153. Okay. And it has two select line which is named as A and B. Then it has enable pin, and it is first enable and second enable. So I am writing it as 1EN, and it has data lines of 1D0, 1D1, 1D2, and 1D3. First mux input over. Now I am showing you second mux inputs. So the control input is enable, and you have four data line again, and those four data line are 2D0, 2D1, 2D2, and 2D3.
What
Okay?
is AB?
Huh?
A and B.
A
What
and
are
B
A
are
and
select
B?
lines.
Okay.
A and B are select lines. I will write here A and B are select lines. 4:1 mux means you should have two select lines, right? So it is having A and B two select line. Okay. Now I will give you the IC pin numbers also, because again you will be using it. So now you can see the IC pin number is 2 and 14 for select line. Okay. Now pin number 1 is for your enable input. Now you will see that all the data input and output for first mux are near to each other. Near to each other means the number follows like third, fourth, fifth, sixth, and seventh. And as you know, you will never get to see 8, because 8 is stored for its 8 and 16 are stored for VCC and ground. So pin number 9 is here, and correspondingly you will see the input pin numbers as 10, 11, 12, 13, and 14 was your select line. Pin number 15 is your second enable pin. Second enable pin. So you can see I did not show the connection for 8 and 16. Pin number 8 and pin number 16 is reserved for VCC and ground. And how many pin IC this is? This is a 16 pin IC. Okay, so we are able to see the internal diagram of 74153. Now the question comes for truth table. All of you make a note of this fast, so that I can go on to the truth table for this. Now you should tell me how many input and how many output should I show for this input, this IC. How many inputs will be there? Control inputs. And how many output will be there? Quickly you
And
should tell.
control input will be
Control input will be
4, ma'am.
4. Yes. 1 enable, 2 enable, A and B will be your control inputs. And output will be only 2 as it is shown here. So
1 by 2.
so shall I start with the truth table for the same? All of you are clear with the block diagram and IC diagram, pin diagram? Okay, so let us quickly do truth table because we have to do designing also today. So truth table, I will give you the idea and you will have to complete the truth table on your own. So as already told, you have two output, that is 1y and 2y, right? And you have 4 inputs, which already one of you have told me. So 1 enable, 2 enable, A and B or B and A, you can write in any order, whatever you like. Let me write it as BA. It does not matter. Okay. Now, 4 input means how many types of output we will have? How many varieties of rows? How many rows I will have? Yes, answer me. 4 variables means how many possibilities will be there? You are there with
16,
me or
ma'am.
you? Yeah. Tell me.
16, ma'am.
Yes, 16. So let us write, but do not jump to write all very fast because at the end we will be having some shortcuts. Okay. So this one, what will be 1y and 2y? Tell me quickly. For the first row, enable, both enables are 0 and select line says 0, 0. When select line says 0, 0, which data input is selected? The first one. So both will be selecting 1 D naught and 2 D naught, right? Both will be selecting 1 D. You can see here, no? First input is 1 D naught. Here first input is 2 D naught. So if the select line is 0, 0, it will select this first input 1 D naught. If the select line is 0, 1, it will select the second input 1 D1 and 2 D1 and so on. Okay. So we will have first one. Now second one is second data line will be connected. So 1D1, 2D1. Same way you will have 1D2 and 2D2. Right? And this one you will have 1D3, 2D3. Now what will happen for these next 4 cases? What is happening in this next 4 cases? Your
The
first,
enables will be 1.
so second
So
enable is 1.
enable, yes, ma'am. So it will be don't cares.
Uh, anyway, we are not giving don't care. We are giving A, B and as 0001. So this A, B will be working for the first mux, but it will be behaved as don't care for the second mux. So second mux output will become 0000 because your enable is high for that. And first mux enable is 0. So based upon this select line, you will get your data output. So same your 1D naught, 2D naught, 2D1 and 1D2 and 1D3 will go on, right? Same you will have but because your second mux is not enabled, you are getting your output as 000. Next, when we go for the next 4 cases, what will happen? What will happen for the next case? I hope you people are understanding what I am doing.
1y will be 0, ma'am. 4 zeros.
1y will be 0 because 1y is not getting, your first mux is not getting selected because first enable is a 1. So first mux will be 0 this time, and your second mux will have its data because second mux is enabled by having a 0 here, because I told you that your second enable is active low. So we are done with our third category of the input when you have 1 0. Last may you will have 1 1. Now when both the inputs are 1 1 and your all the 4 cases here, all the 4 cases here will be 1 1. So what will happen? What will happen for that?
It's 0, ma'am. Both the column.
All the outputs will be 0, and actually I need not had put this 4 rows at all. I could have told in 1 row only that if it is 1 1, it becomes a don't care and output is a 0. I need not have written these last 3 rows. I need not have written, but anyway, one page is going. I am finishing it here. So what you can see, till here, both mux are active. Both mux are active. And in this, what is happening? In this, your first mux is active. First mux. And till here, your second mux is active. And here, both are inactive. So this gives you detailed truth table of 74153. Okay. Now, did I give you homework of designing a 16:1 mux using 8:1 mux? I have not given, I guess. Okay. So I want you to make 16:1 mux using 8:1 mux. You can keep that as homework because we will do designing part here. Okay. And I will okay, so I will tell you that there are 2 possibilities of doing it. I will give the question here so that you do not forget to practice that. What I am trying to say is you need to design 16:1 mux using 8:1 mux. Okay. Now, you all know that what you will do for this is your 8:1 mux is having 3 select line, right? 8:1 mux is having 3 select line. So those 3 select line will become A, B, C. What will happen to D? See, when I say 16:1 mux, you have your 4 input variable, no? First part will be using a OR gate, and second part will be using 2:1 mux as extra circuit. One more you need, no? Only with 8:1 mux you can't work out, right? Yes, can anybody tell me how we will do this? select line, when we have 8 is to 1 marks, we have only 3 select lines, no? And when we talk about 16 is to 1 marks, you are supposed to have 4 inputs. Means 16 inputs you should have using 4 variable. How you will do, what you will do? In the last class, whatever example you did, all the select lines together was giving you enough chance to have all your variables. But now I am not giving you enough chance. What you will do? Okay, I will only give answer for this. Why this question is important? Because this becomes the beginning of designing using mux. Okay, now what I am trying to say is 16 is to 1 mux using 8 is to 1 mux. Now what I am trying to say is you have your this 8 is to 1 mux and you have another 8 is to 1 mux here. Okay. Now these both you have seen, generally we have our select line common, right? So I can say that these select lines are common and you have your 8 inputs here. So it becomes your 1D0, 1D1, so on with 1D7, right? So you will get your 8 data inputs here and your next data input will come from here. It will come from here. So your 2D0 to 2D7, 2D0 to 2D7. So here you will get your 16 in lines you got, right? You got your 16 lines. But how you will show me the connection here? I am drawing each and everything here except one thing. Except one thing. See, if I am giving you, if I am allowing you to put your 2 is to 1 mux here, then there is no problem. You know what to do. So if I call this as my my MSB, if I am taking it as suppose ABCD, ABCD. So this is your LSB, this is your MSB. Tell me the connection. Which select line will be what? You have done this question as homework also. Tell me fast. What will be this select line and what will be these 3 select line if my variables are A, B, C, D? You did your homework on your own, na?
And the first three will be B, C, D, and the last one will be A.
Yes, very good. So you will have your B, C, D here. Let me write with another color. Your MSB will come here, A, right? And your LSBs will come here, B, C, D, right?
Okay.
Now this is what you have done in the last class. You know this. I want you to know the same question. If I don't give you 2 is to 1 marks, what you will do? I'm not giving you 2 is to 1 marks. And why this is important? Because this logic you should understand when you work with other designing question. Again, I have my 1D0 to 1D7 here. And I have 2D0 to 2D7 here. This forms my 16 inputs. This forms my 16 inputs. And I have a 1Y here. I have a 2Y here. Both are my 8 is to 1 marks. And as we know that our select line are always LSBs. Our select lines are always LSB. Okay. Now, how do you do this if I don't give you this 2 is to 1 marks? I'm not giving you. What you will do? Just to give you a hint, I will show you that here enable was grounded. Okay, and here also enable was grounded.
Mom, we are using one of the output as enable.
One of the output,
From 8:1.
you will use enable as output. Enable is an input, na?
Oh, okay.
Enable you can't use at output. Enable is input, so it will remain input. But yes, you can play with enable in this case also. Now you know that your LSBs are connected, B, C, D are connected here. Now I have to do something with this enable. And if you want the first 1D0 to 1D7, 1D0 to 1D7 to make as your first 8 input and 2D0 to 2D7 as second set of input, what you can do, tell me? It is same as what you did, you were doing for decoder. Nobody is applying their head. That's it. Okay, anyway, I will tell you, I can't spend more time here. What we will do is, we will connect our A here. Okay, and with the NOT gate, I will connect this A to this. Now what will happen? For the first 0, 0, 0, 0 to 0, 111, 0 to 7, this will be A will be 0. Because A is 0, this will activate the first multiplexer, and 1 by 1 will be 1D0 to 1D7. And when A is 1, that is 8 to 15, 1000 to 1111, those things, when A is 1, 1 means, here 1 means first mux will not be activated. Here 1 means after NOT gate it becomes 0, and this 0 will go and activate your second mux. So you will get your 2D0 to 2D7 at 2Y. So you will get like this. But 16:1 mux should have one output only. Then what shall I do? Here I can see two output now, but I want one output. What can be done?
OR gate, ma'am.
Yes, you can use one OR gate, because you all know that your data is connected to the input. So this becomes my 16 input and this becomes my 1 output. Using this enable pin, I am playing with this enable pin, I am able to work out. So what happens in for 0 to 7, for that 1Y is connected to the input. So without bothering about what is coming at 2Y, you know, na, when it is not enabled, it will be 0. And if this is 0, Y will be equal to 1Y, right? If 1Y has 0, Y becomes 0. 1Y has 1, Y becomes 1. So your second input become redundant in case of OR gate if it is 0. Same will happen in the other case, that is 8 to 15. This will be 0, 1Y will become redundant and Y will be equal to 2Y. I hope you are understanding this. Okay, so I will write here, if for your reference, if you require, for 0 to 8, 0 to 7 case, for 0 to 7 case, Y will be equal to 1Y. For 8 to 15 case, Y will be equal to 2Y. Why? Because the other one will be 0. Okay, so this is about the using a mux without 2:1 mux. I am designing it. Okay, now I want you to do the next question, and that next question is, if you people have understood this OR question, you should be able to do this question on your own. What I am asking is, I am asking implement function of x, y, z, function of x, y, z equal to summation of 0 to 6, 7 using, now because this is your first design question, I am saying using 8:1 mux. Later we will see how we can do it without 8:1 mux. Okay. Now tell me, how do we do this? I have a 8:1 mux. Okay. And the output input is called as I0, I1, I2, and so on. I have to show the connection of this XYZ. I have to show the connection of XYZ, and my output F should be high when a 0 occur. I hope you remember this implementation. Na? When 0 occurs, when 2 occurs, when 6 occurs, and when 7 occurs, F should be 1. And for all other min terms, F should be 0. I hope you remember this. How do we design this? Again, this is your first design question. You should understand it carefully. Of course, the meaning of this connection and all will not come now because I have given you 8:1 mux. If I give you 4:1 mux to design the same thing, then this logic will come into picture. As of now, this logic is not coming into picture. You have to think something else. You have to think that what I have to do so that when a 0 occurs for XYZ, when a 2 occurs, that means when XYZ is 0, 0, 0, when XYZ is 0, 1, 0, when XYZ is 1, 1, 0, and when it is 1, 1, 1, all these 4 cases, F should be high. What can be done? Think over and tell me, and I will take your attendance by that time. I hope you have written the USN of the students or name of the student who are absent today, those 5 students. I am taking the select line as XYZ. What can be done? For 0, 2, 6, 7, something special has to be done. For a 0, for a 2.
0 to 6, 7 should be equal to 1.
Yeah, it should be equal to 1. So how to make it 1? How to make it 1? Making it 1 is connecting it to VCC. Okay. So what will happen whenever XYZ selects I0, I2, I6 and I7, and when F gets connected to I0, I2, I6, I7, I should get a high. So that is why it is connected to VCC. So whenever this combination of XYZ makes the connection of F to I0, I2, I6, I7, F will be 1. And for all the rest, F should be 0. So what should I do? What should be the other connection? What should be the connection?
Ground, ma'am.
Correct. I1, I3, I4, I5 will be connected to ground. I hope you people are clear with this. This is a simple design of implementing a Boolean expression using mux. Okay. So this is how we design. Now the logic comes. If I want to design the same question, implement the same using 4:1 mux now. Now here comes the trick. What trick? This trick only. This trick only comes. Now you have to tell me what I should do and how the connection should be that it will be connecting. Now there are 2 ways now. I will tell you. Listen to me carefully. If I ask you to use 4:1 mux and implement this, what is coming to your mind? Immediately you are thinking, I will take 2 4:1 mux and I connect it in a cascaded form the way this one is connected, and I will do the same thing here. Yes, you can do this. You can do this, but again, in that there are two possibilities. Number one possibilities is using 4:1 mux 2 number. But again, one more possibility is using only 1 4:1 mux. Now here comes the trick. What you will do? I want to implement the same function of fxyz 0267 4:1 mux using 2 numbers. You people can do it, and you should do that as your homework. And if anybody can do, you do using only 1 4:1 mux also. So this one is a homework. This one, if somebody tells me, I will be very happy. This question A, 2 numbers, is your homework. Homework for today.